Hey guys, we're going to look at systems of equations today and by substitution and elimination. So if you have the ordered pairs, how can I tell if the ordered pair is a solution to the system? We're going to go ahead and look at these two examples real quick. So if this is my x, -1 is my x, and -5 is my y, I'm just going to substitute them in. So 4 times -1 minus -5 is equal to 1. So -4 plus 5, that equals 1. That verifies. We're going to check the second equation. So 6 times -1 plus -5 equals 1. -6 minus 5 is equal to -11. So that does not work, right? Just had a moment there, had to check myself. So since the ordered pair is not true for both equations, so ordered pair, not a solution to both equations. So -1, -5 is not a solution. We're going to go ahead and check the next one, -1/2, -3. So 4 times -1/2 minus -3 gives us, -2 plus 3, which equals 1. So that verifies. Let's check the second equation, 6 times -1/2 plus -3. That should equal -6. So -3 plus -3 equals -6. So that also verifies. So -1/2 comma -3 is a solution. When we graph these equations, what a solution looks like is that is the intersection of the two equations. So it's the point where both, that is valid for both equations. So if you remember back to Math 1 or 8th grade maybe, what kind of solutions do we have for the following systems? So just like the one we had for number 3 here, we have one solution because there's one point of intersection. Okay, what happens when the systems don't intersect? We get no solutions. Okay, and that's because the slopes are the same. The y-intercepts are different. Okay, and then what about this one where we have one line on top of the other? That would be infinite solutions. All right, the next one. So solve by substitution. Well, this is a little bit different than what we've seen before because I have squareds in there. So I need to, just like for polars, what I want to do, or parametrics, we want to isolate one of the variables. So we're going to isolate one equation for one of the variables. So I'm going to start with the second one here and isolate y. So -y is equal to -1 minus 2x, and then multiply or divide by -1. So y is equal to 1 plus 2x. Okay, next we're going to substitute y into the other equation. So we get x squared plus 4x minus parentheses, positive 1 plus 2x is equal to 7. Now my equation is written in terms of one variable, so I get x squared plus 4x minus 1 minus 2x is equal to 7. So x squared plus 2x minus 1 is equal to 7. How do I solve this? Well, it's a quadratic, so let's get a 0 on one side. X squared plus 2x minus 8 equals 0. I need to factor, so big X, negative 8 and 2. What multiplies to negative 8 and adds to 2? Well, 4 and negative 2, I believe. So we get, in factored form, x plus 4 times x minus 2 is equal to 0. So using zero product property, I get x plus 4 is equal to 0. Or x minus 2 is equal to 0, so x is equal to negative 4, or x is equal to 2. That's cool and all, but now what about our other y point? So we need to sub into either equation to get y, the y values. Okay? So I'm going to use the second equation, which is 2x, so 2 times negative 4 minus y is equal to negative 1. Actually, let's scratch that. Let's use this equation, a rewritten one. So y is equal to 1 plus 2 times negative 4, so y is equal to negative 7. So I have an ordered pair solution at negative 4, negative 7. And then I also have y is equal to 1 plus 2 times 2, so y is equal to 5. So I have another ordered pair solution at 2, comma 5. So because this is a quadratic and a linear graph, we can have 2 points of intersection. So it looks something probably like this. 1 point here and 1 point here. Let's go ahead and look at the next one. Looks like I have a linear graph and a cubic graph. So we can get up to 3 points of intersection here. So cubic graph, and that's a bad one. And a line through, I can get up to 3 points of intersection. I should have no less than 1. So let's start by, I'm going to take this equation and isolate y. So y is equal to 2 minus 3x. And then let's sub into other equation. So x cubed minus 2 plus 2 minus 3x is equal to 0. Okay, so I get x cubed, those cancel, minus 3x equals 0. I'm going to go ahead and greatest common factor, the one you always forget about, x squared minus 3 is equal to 0. I'm going to zero product property, so we get x is equal to 0, and then x squared minus 3 is equal to 0, so x squared is equal to 3, and x is equal to plus or minus root 3. So I did something funny. Nope, this is good. Okay, so now we need to get our ordered pairs. So I'm going to go ahead and use, to find y, I'm going to use this equation. So y is equal to 2 minus 3x. So y is equal to, let's see, when x equals 0, y is equal to 2 minus 0, so y is equal to 2. So I have an ordered pair solution at 2, 0, comma 2. Let's go ahead and look at root 3. So y is equal to 2 minus 3 times the square root of 3. That doesn't simplify, so we just get root 3 comma 2 minus 3 root 3. And lastly, negative root 3. Negative. So y is equal to 2 minus negative 3 root 3, which turns out to a positive. So I get negative root 3, comma, 2 plus 3 root 3. So again, we have 3 solutions, though we could have 2 or 1 because our graph probably looks something like that. Okay. All right, solving a system by elimination. So remember, elimination, we want to get a matching coefficient but with an opposite sign. So I'm going to go ahead and multiply the top equation by 2 and the bottom equation by -5. You have a lot of options here. So I'm going to get 10x plus 6y is equal to 9, and negative 10x plus 20y is equal to negative 70. Now I just add these up. I'm going to add. So those cancel. I get 26y is equal to negative, this should be 18 because I multiplied. Don't forget to distribute. So I get negative 52. Divide by 26. Y is equal to negative 2. Okay, so how do I get my x value? 2x minus 4 times negative 2 is equal to 14. So we get 2x plus 8 is equal to 14. 2x subtract 8 is 6. So x is equal to 3. So I have an ordered pair solution at 3, comma negative 2. And that is that. How would you check? Check. Okay, we substitute them back in. So 5 times 3 plus 3 times negative 2 should equal 9. I get 15 minus 6. That equals 9. That verifies. 2 times 3 minus 4 times negative 2 should equal 14. So I get 6 plus 8 equals 14. Verified. We have the right answer. All right, last one. So again, solve by elimination. I'm going to multiply the top by negative 2, giving me negative 4x plus 2y is equal to negative 2. I'm going to multiply the bottom by 1, so it stays the same. Okay, time to add. I get 0, 0, 0. So 0 is equal to 0. So this equation makes sense, but we eliminated all of our x values, so we get infinite solutions. These lines are really the same. Okay, what happens when I eliminate? When you eliminate and get like 8 equals 0. So all your x's are gone, but 8 does not equal 0, so we get no solution. And you're done.